Hello everyone and welcome to another Maths tutorial video. Now I'll be discussing Form 4 Additional Mathematics Chapter 3 Quadratic Functions Long Question Example 1. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Alright, let me read the question now. In the diagram, the point 32 is a minimum point of the curve that has the equation y equals to a in a bracket x plus b square plus q. Okay, just for your information guys, so this equation is actually the general form of a quadratic function. Okay, this q stands for the minimum value. Okay, this p is the axis of symmetry equation, which later on you will get x equals to negative p. Okay, and this coefficient of a represent whether your quadratic function is a positive coefficient or negative coefficient. Okay, if it's in the positive coefficient, you get a smiling face like this. Okay, smiling face. If you get negative, you'll get a sad face graph, guys. So this is the brief explanation I've given you regarding this general form of the quadratic function. Okay, in this diagram, as you can see here, this is the minimum point which you have 3, 2, and then the y-intercept which is 0, 38. Continue to read the remaining question. So the question asks to find the value of a, of p, and of q, and the equation of the curve formed if the curve in the above diagram is reflected in the y-axis. So this is the question, guys. I hope you will attempt this question in the future. If you could manage to solve this question, well done. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions now. So without further delay, let us start to begin the discussion of solution for the question part A, followed by the question part B now. Okay, let us begin. So from the question, we know that our minimum point is equals to 3, 2. Okay, let us continue. And then the axis symmetry we can find using this minimum point 3, 2, guys. So how are we going to do that? Okay, let me show you the working. So from the minimum point, we can know that our axis symmetry is equals to 3. Okay, usually this is how it works, guys. Okay, within the minimum point, so these 3 we can use as the axis of symmetry, and then these 2 we can use as a minimum value. Okay, so why x equals to 3 is the axis of symmetry? Okay, let me show you now. Okay, just take this ruler. Okay, at the x equals to 3, it's dividing the two graphs symmetrically, guys. Okay, let me pull this down. Okay, it's dividing the two graphs symmetrically. Okay, let me draw a dotted line here. So this is the reason, guys. So x equals to 3 is the axis of symmetry. So from here, we need to convert this into the general form. So how is it possible? Okay, let me show you now. So x equals to 3. So in order to change back into the general form, so this 3 from the right hand side, we move it to the left hand side. So it will become x minus 3 equals to 0. So moving on to the next step. So what we're going to do is we're going to compare with the general form x plus p, guys. So this x plus p will be used to find the axis of symmetry. So we can easily compare this p with minus 3. So from here, we know that our p gives the value of negative 3. So this is the first answer. Okay, let us continue with the next step. So from the minimum point itself, we know that our minimum value is y equals to 2. Okay, let us continue. So what we do now is we compare with the q value. Okay, remember guys, I've explained in the earlier of the question. So this q value gives the minimum value, guys, or the maximum value depending on the coefficient of the a. So in this case, it gives the minimum value. So therefore, we know that our q value is equals to 2. So this is your second answer. Okay. So let us proceed to the next step. So what we do now is we substitute p and q value into this general form quadratic function, guys. Y equals to a in a bracket x plus p square plus q. Okay, we substitute all the values. So from here you get y equals to a in a bracket x minus 3 square plus 2. Okay, we still have one value left we need to find, guys, which is the value of a. So how are we going to find the value of a? So please hold on, I'm going to show you in the next paper for the remaining working. Okay, to find the to find the a value, so what we're going to do, we're going to use this y-intercept, which is given by the question, the coordinate 0, 38. So what we're going to do, we're going to use this value and substitute into the quadratic function equation, guys. So 38 equals to a in a bracket 0 minus 3 square plus 2. Okay, from here, you should get your 9a is equals to 36. To find a, what you do, 36 you divide by 9. So from here you should get your a is equals to 4. So this is your answer, guys. So let us proceed to the question part B. So the question part B asks to find the equation of the curve formed if the curve in the above diagram is reflected in the y-axis. Okay, let us continue our discussion. So when curve reflected in the y-axis, so the first step what we need to do is we need to sketch the graph, guys. Okay, whenever you meet this type of question, I'm suggesting you to sketch the graph so that you can able to imagine easier. Okay, let me show you the diagram now. Okay, so this is the original diagram which shown in the earlier question, given by the coordinate 3, 2 and y-intercept 0, 38. So when it reflect in the y-axis, so what does it mean, guys? This means that your y-axis, it act as a mirror. Okay, mirror reflection. Okay, so when it reflected in the y-axis, so this 3, 2, it will become negative 3, 2, guys. This is your new graph, and then your y-intercept remains the same. Okay, I'm showing you this dotted line and then this new line to show you that it's reflected in the y-axis, so that you can able to imagine easier, guys. So this is your new graph which I've already sketched for you. Okay, from here let us continue. So from here we know that our minimum point is negative 3, 2, which means the new minimum point we get from the sketching, guys, over here. So let us continue. So within this minimum point we can find two information, guys. The first information, we can find the axis of symmetry, and then we can find the minimum value. Okay, so from here our axis of symmetry is equals to negative 3, where you get your x equals to negative 3. Okay, moving on to the next step, and then you express in terms of general form. So this negative 3, from the right hand side you move it over to the left hand side, will become x plus 3 equals to 0. Okay, so why we are doing this? Because later on we're going to express everything in the general form, guys. So that is the reason why I'm doing this. So x plus 3 equals to 0. Okay, so moving on to the next step, and then you get your minimum value y equals to 2. Okay, how you get your y equals to 2? So from here, guys, so this value always give you the minimum value. Okay, and then the y-intercept remain the same, which is 0 and 38. Okay, so this information is sufficient, guys, for us to form the general form of the quadratic function. So your new equation of the curve we get from here is y equals to 4 in a bracket x plus 3 square plus 2. Okay, so the coefficient a remains the same, guys. The only thing difference is the axis of symmetry, since your graph is reflected in the y-axis. Okay, if you are not sure whether your answer is correct or not, you can find the answer through the reverse method, guys. So from here you get your axis of symmetry is equals to negative 3, so x plus 3 equals to 0, and then from there you get your x equals to negative 3, and here you get your minimum value is 2. So that means your working is correct, guys. Okay, let me put back the question paper for your reference, so please hold on for a moment. Alright, that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give a thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future. Thank you everyone for your support, and I'll see you in the next video.